Dear children, now let's discuss the fourth problem from exercise 5.3. The question is xy plus y squared is equal to tan x plus y. It's a real implicit function because neither x can be expressed in terms of y nor y can be expressed in terms of x. So now we straight away differentiate each term with respect to x because we are interested in finding dy by dx. So differentiating with respect to x. So in the first term, we have got two factors and both are variables. So we apply the product rule. So first, the product rule states that d by dx of uv is equal to du by dx into v plus u into dv by dx. So one factor x can be taken as u and y can be taken as v, and applying the product rule we get dx by dx, that is differentiating x with respect to x, we get 1 into y, that is v, plus now keep u as such, that is x as such, differentiating v, here v is equal to y with respect to x, we get dy by dx plus the next term is y squared. So differentiating y squared, we get 2y. Then differentiating y, that is by chain rule, we get dy by dx is equal to, now in the right hand side we have got tan x. Differentiating tan, we get secant squared. Retain the argument x, and differentiating x we get 1. And differentiating y with respect to x, we get dy by dx. Now collect the dy by dx terms to one end and the terms independent of dy by dx to the other end. We have x into dy by dx plus 2y dy by dx minus dy by dx is equal to secant squared x minus y. So by distributive law, pick dy by dx in common. We have x plus 2y minus 1 into dy by dx is equal to secant squared x minus y. So dy by dx is equal to secant squared x minus y divided by x plus 2y minus 1. This is the derivative of, this is the value of the differential coefficient dy by dx for the given expression. We shall discuss the next problem in the following lecture. Thank you.